In this video, we're going to do lots of examples, 10 examples of using generics in Swift, just basically using functions, okay? So if you are new to Swift, or you've done most of the videos, or you watched most of the videos in my Learning Swift with David videos, thank you very much, first of all. Well done for getting so far. But if you have just found this one video and you want to know how generics worked and you want to know lots of examples of it, this video is perfect for you. We're going to go through 10 examples explaining each one of them bit by bit. With that said, let's just get started, all right? So this function here is a generic function to swap two values. And we can see here, we haven't covered in out yet, but basically these are just basically saying this is passed by reference. So it means their value is going to get modified externally, all right? So when we say swap two values, we can say that we're going to pass in the pointer, the reference to this one first integer here, and then the reference to the second integer here, and within inside of that one we're going to say temporary value is of type t, all right? So we are assigning this local variable to have this one reference, all right? And then we're going to say a is equal to b, and then we're going to say b is equal to a. So basically you are swapping them around. Now as you can see here, it doesn't really matter if we change here these now to double, and we have to add that to here. We change this to double and we run it, it still works, right? And we even change this, it still works, okay? And we can change this to string, and which means we can get rid of this as well, and it still works because this swap two values, it doesn't care about what, it doesn't care about the type. It's just basically swapping the references, the pointers, the addresses of A and B in here. So the type is of no relevance to it. Now the compiler knows that David and Thorn, or first, let's just call it first, and second here, they have the same type, so they can both be used on this swap two values here. So this is a nice introduction to you to in, out, passing by a reference, and also to a swap function as well. The next function is find maximum value, and as you can see here, it's a generic function to find the maximum value in an array. And once again, we're using collections of type t, and now each t has to conform to comparable. And as you can see on the right hand side, if you're not sure what comparable does, you can have a quick read of it here and see the different examples that are available for it. Basically, it's anything that can be compared, so equal to, less than, or greater than, and so on. So we're asking, first of all, if the array is not empty, let's continue to the next line. If it is empty, then we'll just return nil anyway, because we can't compare nothing, all right? And otherwise, we're just going to return the maximum, so that the biggest element in the array, all right? And in this here is obviously 5. So once it does get, it does get to this point, it's saying, hey, give me the highest value in this one array. Now this doesn't care, once again, what the elements are in this. If we just said 1.0 and 3.2 and 5.1 and 2.2 and 4.1, as you can see, this still works perfectly fine, because this is now an array of doubles, and because this is a generic type, and because double conforms to comparable as well, this generic function works fine. So let's move on. The next function is going to check if an array contains a specific value. Okay, if you don't know what equatable does, then here's a quick brief description on the right hand side what it does do. But basically it's just checking to see whether or not they are equal, all right, whether the items in the array are equal. So we are taking an array as the first argument, and then we're taking a value of type t in the second argument. So now it's going to return true if that array, if one of the items in this one array matches, is it equal to the value item here, all right? And this is why it's really nice to be able to do generics, because they teach you a lot about collections too. All right, and so now we have a string array of apple, banana, and cherry, and which we can see through type inference, we have a string collection, and array contains value string array. And we can see that the container does contain, or the collection does contain a banana. However, if we now change this to an int array, and we just go 1, 5, 7, and we change this to say 7, and we change this to int array, you can see here that contains, let's just say 7. You can see here everything compiles perfectly fine because this array is function is generic, and because integers are equatable by default anyway. Moving on, so the next one is a generic function to filter elements in an array based upon a condition. So the function is called filter array, and it takes a type t. So t doesn't have to conform to anything, but it's going to take a collection of type t. And then we are passing a function type as the condition parameter. And in here, we are basically just going to use the filter function here. And we've seen this in other videos as well. So we're going to say array and then filter based upon the condition. And so here, when we use the usage, we've got a collection of integers, and filter array, we pass in the numbers, and then with the trailing closure, we can check to see whether or not they are actually even numbers. So we've been through this in the past, and obviously here we could change this to array of doubles as well, and just change one of these to 3.9, all right, and run this. But you can see here it's unavailable for floating point numbers use truncated remember instead. Okay, so you can see here that it's only based upon the mathematics inside that we're having a problem. The function allows it anyway. So let's just say if this is equal to 0, you can see this allows it perfectly fine, all right? But it was just because of the modulus is not working properly. But so this is another example of using generics to have generic functions. The next one is a map array, a generic function to map elements into an array. A generic functions to map elements in an array to a new array. So as you can see here, we are taking two types here, a type t and a type u. And the first parameter is then array of a collection of t. And now we're transforming, so we're taking a function type that takes a type t and returns a type u, and then the map array will return a collection of u's, okay? And we're using nothing more than the map function anyway, so this is basically just a wrapper for the map function, and it just goes to show you that generics is already built in. It was already built in anyway, and when we use it, what we're saying here is we're going to get the $0, so the first index of it is we are going to then map basically to a string all the time, and it outputs then, it goes from integers to strings, okay? So this is another great example of using generics, but collections have all this built in anyway, and as you can see here, it was already built in to it. So we're doing nothing more than we're wrapping already pre-existing high-order generic functions. Slowly you're going to notice a pattern here, a generic function to reduce an array to a single value. So we look at the implementation once again, and we can see we're taking an array, a collection of type t, and then we're saying what's the initial result is of type u, as here, and then the next partial result. So this is another function type passed to the function, and it's going to be the next partial result. And as you can see here, we're doing nothing more than basically wrapping the reduce function on collections anyway. And this is already a generic function. And so we are declaring that the array reduce should return a single value, right? A single value, but inside of it, it's always going to be passing on the previous value to that. So if you haven't seen the reduce function yet, I would suggest you do look at it. So we can see here the values are, we are giving it an integer collection. 1, 2, 3, and 4 are the items, and we are passing the initial values. And we're saying the initial value is 0, and through every single item they're going to take the previous result and add that current item to it and return the sum of those two items, and it ends up equaling 10. So the next function, the index of value, this pattern is really occurring now. As you can see, we are taking a function with the generic t should be equatable. So we want to be able to compare whether or not two elements are of the same type and have the same value. and we are passing in an array of type or collection of type T, and we're passing a T value in as well. And what we want to return is the index, the index of that one, or the first index of that one value T. And we're doing nothing more than saying, hey, take this array and call the first index function on it to find that one value, okay? And here we do apples, banana, and cherry, and we say the index value in fruits of then the value of banana, and we get index 1, okay? This is really not that difficult to understand, but as you can see here, as long as you start learning equatable, comparable, identifiable, hashable, and so on, you'll start realizing how powerful generics are and how often you see generics anyway. So we're getting closer and closer to the end, a generic function to combine two arrays. So we're now saying combine arrays and of type T, and we have then the first parameter is the first array of a collection of type T, second array is a collection of type T, and what we want to do is return a collection of type T. And as you can see here, because collections already implements the addition sign here, we can literally just return this already. And so you can see here we combine the two arrays and it's nothing more than done. So as you can see here, this whole video, is it teaching you about generics or is it teaching you about collections? You know, and you're kind of seeing everything that we need to see how we can use collections here. And in the up and coming video where we're going to finalize it all, you really will learn of how a collection is kind of created in the background. So let's move on. Now we have a generic function to reverse an array. The pattern's continuing. We have an array of type T, so the generic value is T, or generic type, sorry, of T. And then all we're doing is we are returning a collection of T, and we are saying array reversed. So this is just returning, it's basically just wrapping this one array reversed function. But yeah, that's it. And here we see original array, 1, 2, and 3, reversed array, no surprise, and we get 3, 2, and 1 as the results. And the final one, a generic function to create a dictionary from two arrays. So this function is called create dictionary, and it takes two generic parameters here, K and V. And then the first parameter is a collection of type K. The second is a collection of type V. And we're going to return a dictionary with then the key of type K and then the value of type V, and this is going to be optional as well. So it could be that it just doesn't work. So in order for us to do this, we have to know that the number of items in each array is equal to each other. Otherwise, it's not going to conform to this, because we haven't said that V is optional. We've said that V has got to be there. All right. And so if the keys counts or the keys values, the keys count and the values count don't match, we return nil because we can't make a dictionary from this. Otherwise, then we're calling a dictionary unique keys with value, and we are zipping them together basically. So this is an introduction now to dictionaries. And so we have here 1, 2, and 3, 1, 2, and 3 in the integer form. The first is in then the string form, and we create them together and we create a dictionary. So this is now a very, very good introduction to generics and how can you use generics. I'm a big fan of jumping straight into demonstration, right? Always demonstration rather than lots of explanation. And now it's really time, like I said in the previous video, for you to start to practice with your knowledge that you have now over the last two videos and see whether or not you can implement this. All right, and the only thing you've got to work out here is type alias. Okay, this is the thing, this is the, if you can't work it out, this is type alias. All right, so see whether you can implement this entity store, see whether you can implement this, and if not, don't worry about it. The next video is going to implement this. If you've got this far and you understand all of these 10 examples, well done. If you didn't, go back and recheck them again, and if you want another 10 examples, then I might do another one for you maybe. But anyway, thank you very much for watching. I hope that you've got something out of this one video. I hope that you've learned something. I hope you are now, if you've been through every single video so far, you should be pretty competent in writing Swift code. Now, if you've just been watching these Swift videos and you haven't been actually practicing it, it's not necessarily your brain, just because you've learnt it, that is actually making you a Swift programmer. It's the usage, right? Your fingers can just write this stuff. Your brain doesn't have to think about it. It's literally your fingers know, okay, I've got to write this because I've written it so many times that when you write this function, you take this parameter and return types, and then tab in, space, enter, and then this comes and that comes, and so on. And then your fingers need to do it to learn what to write. And slowly but surely, you'll notice what clean code is. And when you start writing clean code, you know it's good code and it's working code, and you should be able to read it a lot easier and a lot faster. And when you see code that's not clean, that's where you start thinking, okay, I can see where the errors are in this now, and the readability is not very well. So if you've got this far and you have been practicing all the time, you have been using examples all the time, and you have an end goal, and you've got to generics, really, really well done. Give yourself a tap on the back, pat on the back, all right, because you've done really well. But we're not finished yet. So, you know, you've finished chapter 1. We've still got a whole bunch of chapters to go, but you should be very proud of yourself, all right? With that said, if you've got any questions, feedback, or concerns, or anything like that, then let's start a conversation in the comment section down below. The only reason I do these videos is for you. I don't do them for anything else. If I can get one or more people if I can inspire at least one person or more with these one videos today or in a few years' time, that's all I care about. I don't care about anything else. That's it. I want to pass on my knowledge to other people, and I want to hopefully assist you to get a job in this one field. And also at one point, if you're able to teach other people. It doesn't have to be through social media or through videos. Just teach other people and say, this is how I've learned it. This is where I've got the source from. Pass the videos on for them, other people to learn as well. Thank you very much for watching. I will see you in the implementation of this entity store. Ciao, ciao, and goodbye.